Hello, welcome to Chapter 7, homework questions 24 through 29. Question 24. Each table below represents an exponential function of the form y equals a times b raised to the x power. Copy and complete each table on your paper and find the corresponding equation. So on the first example A, you can see your x value is increasing by 1, and we need to figure out what that multiplier is. So 1.2 times what is going to give you 3.96. Well, obviously, we can't just look at that and decide what it is, but what we can do is we can work backwards. So if we're asking ourselves 1.2 times what value, and we'll call it b because that's our multiplier, is equal to 3.96, well, then we can divide 1.2 by 3.96 and get what that value is. And since they tell us that these are exponential functions, we know we're going to get a value that when we multiply by 3.96, we should get 13.068. And so once we divide, we get b is equal to 3.3. So if we take 1.2 times 3.3, we should get 3.96. And if we take 3.96 and multiply it by 3.3, we should get 13.068. So now we have the multiplier, or the b value, and now we need the initial where we're starting, but that's given to us in the table. When x is 0, y is 1.2. So that's enough to write our equation. So y is equal to our initial 1.2 times the multiplier of 3.3 raised to the x power. Now we do need to also complete each table, so let's go ahead and multiply the next value, 13.068, times the 3.3, and then that'll be 43.1244, and then we will multiply that by 3.3, and we're going to get 142.31052. Alright, now on part B. So B in the table still gives us that initial value, so that's good, we have that. But now we need to figure out what the multiplier is. And the problem is on this one is we don't have the next term after 5. So whatever is going to happen, this 5 is going to get multiplied by b, and then it's going to get multiplied by b again to get to the next term. So now we're going to say 5 times b again should equal 180. And so we can divide both sides by 5. And b times b is b squared. So we actually get b squared equals 36. And so what times itself gives you 36? Or you can take the square root of both sides, and we get b is equal to 6. And technically it's going to be plus or minus 6, but because of it's a multiplier, you can see our numbers are going up here, we're going to get 6. So b is equal to 6, so now we have the multiplier, and we have the initial, so we can write the equation. Y is equal to the initial of 5 times the multiplier of 6 raised to the x power. Alright, and now we can finish filling in the table as well. 5 times 6 is 30. 30 times 6 is 180. 180 times 6, it's supposed to be times 6 there, is 1,080. And then 1,080 times 6 is 6,480. So we've completed the table, and we have written the equation for both of them as well. Question 25. Brianna is working on her homework. Her assignment is to come up with 4 representations for an exponential function of her choosing. She decides it is easiest to start by writing the equation. So she chooses y equals 1200 times 1/2 raised to the x power. Help Brianna create the other 3 components of the web. So remember, the components of the web include the equation, includes the graph, a table, and a situation. So we need to do the other 3. So we can start, I have the graph on here, so that's one that we need to do. So we can go ahead and graph that. And by graphing that, we're actually, maybe one of the easier ways to do it is to create a table. So we'll create a table, and then we can graph based on that. So we can start with negative values. We can start with, positive, whatever, but let's make sure we get a nice couple of points on here. So I just did -2 to 2, and we'll go from there and kind of see what we get. So if we plug in -2, that's going to give us 4 times 1,200, so that's 4,800. And then we plug in -1, and that will be 2,400. And remember, all I'm doing is saying y equals 1,200 times 0.5 or 1/2 raised to the -2. Same thing on the next one, raised to the -1. But once you see that pattern, we know the multiplier is 1/2, so everything is just getting multiplied by 1/2. So once we see that, we can actually just continue that pattern on down as far as we want to. Let's go a little bit further. We'll get down to 150, and then 4 we can do is 75. And we can go a little bit farther if we want to, but we're starting to get down to some smaller numbers here, and that will give us enough to be able to graph the equation. And so I'll do one more here. And remember, we're not going to ever get to 0. We'll get closer and closer because we keep taking half of something, but we're not going to actually get to 0. So the graph would look like starting at -2 would be at 4,800, -1, 2,400. So I'll mark my x and y axes off and then plot those points. So I went ahead and went up by 250s, and then the x-axis I just went up by 1s. So I've plotted the points, and now it is a continuous graph, so I do want to make sure I connect the points with a nice smooth curve. Once again, not crossing the x-axis there. We have a horizontal asymptote there where the graph gets close to as x gets larger. So that's one representation. The table is another representation. And then the third one we need to do is include a situation. So we just need to think of something where we start with 1,200, and then for every, value of x, it goes down by 1/2. And so I'll let you come up with your own situation with that piece of information, but you could do something with population, where population of deer started at 1,200, and every year, in terms of it, lost half its population. So, there's a couple different things. You can deal with money as well. So those are a couple options you could use for that. But it is an exponential decay, so make sure you are describing a decrease there. Question 26. Sketch the graphs of y equals x squared, y equals 2x squared, and y equals 1/2 x squared on the same set of axes. Describe the similarities and differences among the graphs. So I'll do 3 different colors here. First one I'll do is the y equals x squared, your most basic quadratic. And to do this, we can just create tables. So we want some negatives and some positives, and since I'm just squaring it, I know -3 squared, at least on a 10 by 10 graph, would give me 9. So if I go any higher, it won't fit, at least on my graph that I have to the right. And I'm just going to square these numbers. Remember, when you do square a negative, it does become a positive. It's the x that's being squared, so this is -3, the quantity squared. So we get 9410149, so we'll go ahead and graph that one. So 00112439, and then on the other side you have that symmetry. And we are going to go ahead and graph it, so we're going to connect it with a nice smooth curve. And we're also going to label it because we're going to have 3 graphs on here. So y equals x squared. Next one is y equals 2x squared. Now if you think about that before you start picking your values, is all your values from the previous table are now going to get multiplied by 2. So if I choose -3 again, it's fine, but then it's going to be 18. So I'll stick with the same numbers but some of these we will not be able to graph on the 10 by 10 I have. So negative 3, this is 2 times negative 3 squared. So that's 2 times 9, and that's 18. Negative 2 squared was 4. 4 times 2 is 8. Negative 1 squared is 1. 1 times 2 is 2. So like I said, all we're doing is taking these values over here that we've already created and multiplying each of them by 2. And so 0 squared is 0 times 2. And then you'll notice once again the symmetry on the other side. So we'll go ahead and graph this. Negative 3, a little bit higher this time, so I won't graph it. Negative 2 is at 8. Negative 1 is at 2. Still at 0, 0. 1, 2, and 2, 8. And so you can see on this one it's a little bit more narrow than the original one. So this is y equals 2x squared. So same shape, but a little bit more narrow. And then we will do the third one in green. So we have y equals 1/2 x squared. So now, just compared to the same thing we just did, where the x squareds got multiplied by 2, now they get multiplied by 1/2. So I'm going to include a couple extra points because now since they're getting multiplied by 1/2, we'll be able to fit actually a couple more points on here. So negative 4, if we square negative 4 and then take half of it, so that's 16, half of 16 is 8. Now I'm just going to go back to my blue table. So I have negative 3 was 9, negative 3 squared was 9, 9, half of 9 is 4.5. Negative 2 squared was 4, half of 4 is 2. Negative 1 squared was 1. Half of 1 is 0.5. 0 squared was 0, half of 0 is 0, and then you start to see the symmetry again. Because whether you square a negative 3 or positive 3, you still get 9. And same is true for the rest of them. So there are those points. Now we'll be able to graph negative 4. We'll go to 8. Negative 3 is 4.5. Negative 2 is 2. Negative 1, 0.5. And then once again, 0 is still a point. And then we graph the symmetry on the other side. So at 2, we're at 2. At 3, you're at 4.5. And then at 4, you're at 8. And so on this one, you can see that the graph has gotten a little bit wider compared to the other two. So now that we have sketched the graphs, we've labeled them on the same set of axes, we want to describe the similarities and differences among the graphs, which I've kind of been talking about as we're working through them. And so we can see the similarities is that they're all parabolas. They all represent a quadratic equation. Some of them, maybe the differences is that the one that has the 2x squared seems to be rising a little bit more rapidly, and the one that's the 1/2 x squared seems to be rising a little bit more slowly. And that's why you can see, like, in terms of if you're looking at the width, so to speak, of the parabola, you can see it's a little bit wider, whereas the 2x squared, because it's growing more rapidly, it's a little bit more narrow. And so make sure you write something to describe those similarities and differences among the graphs. It does say among the graphs. I included equations are all quadratic equations, so it's a little bit beyond what it's asking, but I saw it as a similarity, so I went ahead and wrote it down. Question 27. Write an equation or system of equations to solve this problem. Morgan started the year with $615 in the bank and is saving $25 per week. Kendall started with $975 and is spending $15 per week. When will they both have the same amount of money in the bank? So we want to start off with a let statement. We want to let the money in the bank. So I'll just say let M equal the amount of money in the bank. And then let, what are we spending per week? Let W equal the number of weeks, which is your time. And so Morgan started the year with $615 and is saving $25 per week. So the money in the bank is going to be $615 plus $25 every week she's saving. Whereas Kendall is starting with M is equal to the money in the bank, $975, but she is spending $15 per week. So her money is going to be decreasing. So I set it up as a system. We can go ahead and solve this using the equal value method because M is the amount of money in the bank for both of them, and we do want to know when they have the same amount of money in the bank. So we're going to set these equivalent to each other, and then we will go ahead and solve. And so I had a typo in my equation. It's 975, and so I fixed that and then went ahead and solved, and I get W equals 9. So that means in 9 weeks they're going to have the same amount of money in the bank. And so make sure you write that out to answer the question. Question 28. Examine each sequence below. State whether it is arithmetic, geometric, or neither. For the sequences that are arithmetic, find the formula for T of n. For the sequences that are geometric, find the sequence generator for T of n. So on the first one, A is 1, 4, 7, 10, and 13. So hopefully you see pretty quickly that we can add 3 each time, and it has to be throughout the entire sequence. So this one is arithmetic. And then we want to be able to write the formula for T of n. So that would be T of n. We know what the difference is. We're adding 3, but we need to work back to find the initial. So we know it's 3 times n, and then go backwards to your first term. So you got to work back this way to find the first term by subtracting 3, and that's where the negative 2 comes from. So T of n is equal to 3n minus 2. Part B, if we're adding, it'll be plus 5 and then plus 7 and then plus 9 and so on. So it's not arithmetic. If you try to multiply 0 times anything to get 5, that's not going to work either. So it looks like this one would be neither. And so that's all we need to do for that one. On the next one, C, 2, 4, 8, 16, 32. So you're adding 2 and then 4, so it's not constant, but you are multiplying by 2, 2, and 2. So it is geometric because you are multiplying. So geometric there. And then, so for the sequences that are geometric, find the sequence generator for T of n. So we don't need to write the equation, we just need to write what the generator is, and that's R equals 2. For part D, we have plus 7, and plus 7. So once again on this one we have arithmetic. And we know that T of n, and since we're adding 7, that's our constant that we're adding each time. But then once again, where do we start? We have to work backwards, subtract 7 from 5, and that will give us a minus 2. On E, it looks a little different here. We're going from x to x plus 1 to x plus 2 to x plus 3. But if you look, all we're doing each time is adding 1. If we add 1 to x plus 1, we get x plus 2. If we add 1 to x plus 2, we get x plus 3. So this is arithmetic, even though it's not just numbers, but it is still arithmetic. And we can state that the equation for this is, well, we know we're going to add 1, so that's 1 times your n, 1n or just n. And then as you work backwards, you're going to have to subtract 1 from x, which would be plus x minus 1. So you can see you have your 1n, which is what you're adding every single time, but then you're adding that initial, which is actually x minus 1. And then on the last one, F, the numbers are going up too quick to be adding a constant, so we can look at multiplication. 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. So it is geometric on this one. and we just need the R value, and since we're multiplying by 4, that is our sequence generator, so R is equal to 4. And question 29. Scientists hypothesized that dietary fiber would impact the blood cholesterol level of college students. They collected data and found R equals negative 0.45 with a scattered residual plot. Interpret the scientists' findings in context. So remember, the R value is your correlation coefficient, so it needs to be either close to 1 or negative 1 to be considered strong. The closer it is to 0, the weaker it is. And so this one, between 0 and negative 1, is closer to 0, so there seems to be a weak negative linear association. So the R being negative also indicates that the data is decreasing. So we'd say, once again, it's probably a weak negative linear association. Interpret this, scientists' findings in context. We could say something about that as dietary fiber is increased, the blood cholesterol drops. And then we could also look at the variability by taking R squared. And once we figure out that value, which is 20.25%, we could say something about the 20.25% of the variability in blood cholesterol can be explained by a linear association with dietary fiber. So just kind of talking through that as we look at it, but let's just go ahead and start with the R value itself and write down that it has a weak negative linear association, and we also know as the dietary fiber is increased, the blood cholesterol does drop. So there's the first statement about just the R value itself. Now we can also find what R squared is. So we'll take the negative 0.45 and square that, and that will give us a value of 0.2025, but we're going to want to write that as a percent, so that's 20.25%. So we can also talk about the variability as well. So those would really be the things that we would want to include to make sure that we are interpreting the scientists' findings in context, not just talking about the R, because once we have the R, which is the correlation coefficient, we can square it and talk about that variability and what other factors could be involved as well.